Now, I'd like to give a couple of examples here of things that we've done and lessons that we've learned. Marine energy is very, very important to us, and we believe is very, very important to the UK and to Northern Ireland. And there are a couple of lessons that are inherent in what we see in the marine sector that we can carry forward. The first is that cost is the challenge. Cost is the challenge for innovation in this sector. So on the vertical axis there, you see the cost of energy, and you see a comparator line, which is the target cost, the blue line at the bottom. A couple of things there. Firstly, why is cost so important? Cost is important because there isn't a green consumer out there. Therefore, your chances of actually selling anything at a premium into the green market today are very slim. Therefore, your best chance of succeeding in the market is by having a product which is inherently competitive with the existing offerings. In this case, supply-side technologies, but energy efficiency kicks in as well. So cost is the prime driver for innovation in this sector. A number of things happen. Firstly, traditionally over time, with experience, you see costs come down. We don't think that's going to work for a number of reasons. The first is that if you do it in this way, and just look along at the red line there, a slow learning over time as you gain more experience. For every unit that you put in that costs more than the dotted blue line at the bottom, somebody is having to put money on the table, money that they would not have to do otherwise. Is that money an investment or is it a waste? That's the crucial question. But if you can bring that red line down to the green line by accelerating faster the learning effects of developing new technologies, then you can reduce the cost, literally the area under the curve there, and you reduce the investment required or indeed the cost to the public purse. So actually focusing on reducing costs more quickly is very important, and it probably isn't enough to simply do lots of something on the basis that it will eventually become cheaper. You can actually focus your efforts very significantly on new technology approaches. The comparators are quite interesting as well. At the moment, we've just put up a dotted line there, the blue line, suggesting that that's the target cost. That's the cost of other technologies in the same market. But that in itself moves around over time. As carbon becomes priced in the European emissions trading scheme, then a carbon price will actually increase, will lift that dotted line up, and will make it easier to achieve cost parity. Any other form of support and subsidy will also effectively raise that line. It'll raise the point at which you can achieve cost parity. So the renewable obligation will do exactly the same. So it's an interesting picture because it shows what the challenge is. But we believe very much that the focus on innovation and on accelerating innovation should be on bringing cost down as quickly as possible through directly focused work. The Marine Energy Accelerator is an interesting piece of work in itself. It's a program that we've been running now for a couple of years that's still got some way to go. And what it says is there are 3 different things that we want to understand about marine technology that we're going to bring to bear. The first strand is on new device concepts, completely new ways of looking at wave and tidal energy, because we recognize that one of the issues here is generational development. So some of the very early stage devices may or may not be ultimately the winners in this. And there is a case for going back and using one's learning of what's coming out at the moment to say, are there new devices that we should be taking forward? The second area of development is Strand B, which is all about component technologies. The reality is that most of these devices are owned by relatively small companies who are doing a great job in developing their device within relatively limited resource constraints. And those resource constraints typically don't allow them to develop the deep areas of expertise they might require in certain areas of their work. So, power takeoff systems, the ability to tune a wave and tidal device to the particular form of wave pattern that you're working with at that time, and so on and so on. So component technologies, very important, and those can be generic across a whole number of device developers and devices being put forward. And lastly, Strand C, which is all about operations and maintenance. A lot of people look at these devices and say, right, you've convinced us that one of these can be cost effective. Convince us now that you can put a whole bunch of these into the water and actually run them for a number of years without difficulty. Operations and maintenance costs have been much, much higher in people's experience in the wind sector than they ever anticipated, and people are looking forward from the investment perspective and saying, we just want to believe that in the wave and tidal space, you've got a handle on this. So we're doing a lot of work on that. Combine the 3 effects, and this is at the moment a schematic, and we'll put it in the public domain when we get further kind of positioning on it, we're pretty convinced that we can actually move the industry onto a faster cost curve, essentially able to reduce cost more quickly than it would otherwise do. And that is really, really important, because there is one key comparator, which essentially is getting the cost down to the point at which, with the current renewable obligation support, with the current price of carbon, it is cost competitive in the market. And the work that we're currently doing suggests that we'll be able to get to that point with the first 100 megawatts of devices having been deployed. Now, that may sound a lot, but actually the alternative, which is learning the hard way, gets you there after about a gigawatt, 10 times more. So if you want to speed up by an order of magnitude the rate at which you can get to the point of cost competitiveness and reduce, therefore, the investment cost or the subsidy cost that's involved in getting there, this kind of approach really does make a lot of sense.